This is Euclid Book 10, proposition number 19, and I wanted to clarify the lemma of Euclid Book 10, proposition number 18, because we're going to use it in Euclid Book 10, proposition number 19. Alright, here's how that works. Let's say we have two lines here. We have A and B, okay? Now then, if we have two lines A and B and they are commensurable, that means that some number can measure the line of A and some number can measure the line of B. It is automatically known that if there is a number that measures A and there is a number that measures B, then there is going to be some area that's going to measure the area of the square of A and the area of the square of B. Now, how did we get these? Okay, we took the length of A and we did it 4 times. This is the length of A, so is this, so is this, so is this. That's how we form the square. And inside that square is an area. Okay? The same thing was done with B. We took the length of B and we made a square out of it. This is B, this is B, this is B, this is B. And that's the area that was made and contained by the 4 lengths of B. Okay? So, if there is a number that measures both A and B, then there's automatically an area that will measure the area of A and the area of B. So that means that A and B are commensurable in length, and they're automatically commensurable in square. That also means that the number that measures A and B, okay, is rational, and so is A. Okay? We're going to establish that B is irrational right off the bat. Well, now we're going to say that A is also rational because A is commensurable with B, and there is some area that makes A squared commensurable with B squared automatically. So if B is rational and A is commensurable and it's commensurable in square also, then A is rational. Likewise, if there is some area that will okay, let's say there's an area that measures the area of A and the area of B. But there is no number that will measure A and B. Is A still rational? Yes, because it is still commensurable in square. Now, if there is an area let's say there's an area that will measure A, that will also measure B, and we also find out later on that there actually is a number that will measure A and B. Is A still rational? Yes. The only time that A is not rational is if there is no number that will measure these two lines and there is no number that will measure these two areas. Then A is irrational. Otherwise, it's rational. Okay, so let's go through Euclid Book 10, proposition number 19. And it says, the rectangle contained by rational straight lines commensurable in length is rational. Okay. For let the rectangle AC, this area right here is represented by the rectangle AC. It is contained by rational straight lines AB and BC. So line AB is rational, so is this. Okay. And they are commensurable in length. That means there's some number that will measure the length of AB and the length of BC. I say that AC, the rectangle AC, is rational. We're not going to say that this rectangle is rational. For on AB, let the square AD be described. So, we have this great big square AD. It's going to be described. Therefore, AD is rational. Right off the bat, we are now going to say that AD is rational. And this is by Euclid Book 10, proposition number 4. Or not proposition. Euclid Book 10, definition number 4. Okay? And since AB is commensurable in length with BC, since this and this can be measured by some number, while AB is equal to BD, the length of AB is equal to the length of BD, therefore, BD is commensurable in length with BC. This length right here is commensurable with the length of BC. That means some number can measure both this and this. And As BD is to BC, so as DA is to AC. Okay? As BD is to DC, so is AD to AC. AD to AC. Those are in a ratio. And that ratio is defined by Euclid Book 6, proposition number 1. Therefore, AD is commensurable with AC. So the length of AD is commensurable with the length of AC. And this is defined by Euclid Book 10, proposition number 11. But AD is rational. Okay? The length of AD is rational. Okay? And actually, not only is the length AD is rational, but the entire area, the entire square area of AD is rational. We already said that. Therefore, the area of AC is also rational. And this is by Euclid Book 10, definition number 4. The area of AC is rational by Euclid Book 10, definition number 4. Okay? Say it again. Euclid Book 10, definition number 4. And that is the whole proof. I will tell you more in a future video, so I want you to stay tuned.